Hi everyone, welcome to the Instrumentation Technician. Have you ever seen a factory line where machines move with perfect timing, sensors detect every product, and motors run automatically without human control? Behind all that precision lies one of the most powerful inventions in industrial history, the PLC, or Programmable Logic Controller. In this video, we'll explore what PLC programming really means, how it works, and why every modern industry, from the Gulf region's oil fields to Western manufacturing plants, depends on it. 1. What is a PLC? PLC stands for Programmable Logic Controller. It's basically a small industrial computer that controls machines and processes. But unlike your home computer, a PLC is built to work in extreme conditions, high temperatures, dust, vibration, and electrical noise. In simple terms, the PLC is the brain of an industrial system. It takes inputs from sensors, processes those signals according to a programmed logic, and sends outputs to actuators like motors, valves, and relays. For example, imagine a water bottling plant in Dubai. Sensors detect when a bottle arrives at the filling station. The PLC processes that signal and commands the filling nozzle to open for a specific time. Then it tells the conveyor to move the bottle to the next stage. All this happens in milliseconds, perfectly timed and controlled. 2. Why PLC was invented? Before PLCs, industries used complex relay panels, hundreds of relays and timers wired together to perform simple control tasks. If a process needed to change, technicians had to manually rewire the entire system. In 1968, engineers at General Motors needed a better solution for their automotive production lines. They wanted something flexible, reliable, and programmable, and that's how the first PLC was born. Since then, PLCs have evolved from simple logic devices to powerful industrial computers capable of handling thousands of I/O points, communicating over networks, and even performing advanced diagnostics. 3. How PLCs work. Let's look at how a PLC actually works. A PLC system has three main parts: input, processor, and output. Input section. This part receives signals from sensors like limit switches, pressure transmitters, flow meters, and proximity sensors. The signals tell the PLC what is happening in the field, for example, whether a valve is open or closed. Processor or CPU. This is where the main logic or program runs. The CPU continuously scans all input signals, executes the programmed logic, and updates the output devices. Output section. This part sends signals to control devices like solenoid valves, contactors, alarms, or motors. This entire cycle, read inputs, execute logic, update outputs, is called the scan cycle. And it happens hundreds of times every second. 4. What is PLC programming? PLC programming means writing instructions that tell the PLC how to respond to inputs and control outputs. Think of it as teaching the PLC how to think logically. The most common PLC programming language is ladder logic, because it looks like a ladder, with rungs representing control operations. Each rung is a simple logic condition, for example, if start button is pressed and stop button is not pressed, turn on motor. There are other languages too, like function block diagram, structured text, and sequential function chart. But ladder logic remains the most popular because it's easy for electricians and technicians to read. 5. Example of PLC logic. Let's take a simple example. You have a motor that should start when you press a green button and stop when you press a red button. In the PLC program, the green button input is assigned to one address, let's say I0.0. The red button is I0.1, and the motor output is Q0.0. In ladder logic, you create a rung that says, if I0.0 is on and I0.1 is off, then energize Q0.0. When you press the green button, the motor starts. When you press the red button, the motor stops. Simple, right? That's the beauty of PLC programming: logical, visual, and reliable. 6. PLC brands and types. In the global market, you'll find several major PLC brands. The most famous ones are Siemens, Allen-Bradley, Rockwell Automation, Schneider Electric, Omron, Mitsubishi, and Delta. In the Gulf region, especially in oil and gas plants, Siemens and Allen-Bradley dominate due to their robustness and integration with SCADA systems. In Western industries, Rockwell Automation and Siemens are often used for manufacturing and process control. PLCs come in two main types. Compact PLCs, which are small and suitable for simple machines. Modular PLCs, where you can add extra modules like analog inputs, communication ports, and special I/O cards for larger systems. 7. PLC and SCADA integration. PLCs rarely work alone. They are usually connected to a SCADA system, supervisory control and data acquisition. While the PLC handles field-level control, SCADA provides real-time monitoring, data logging, and remote operation from a control room. In Gulf refineries, water treatment plants, and power stations, PLC and SCADA integration ensures safe and continuous operation, even in harsh desert environments. 8. PLC programming process. The process of developing a PLC program involves several steps. Understanding the process or system requirements. Preparing input-output lists and control logic diagrams. Writing the program using the chosen PLC software, such as Siemens TIA Portal or Allen-Bradley RS Logix. Simulating and testing the program. Downloading it to the PLC and commissioning the system. A good programmer always follows structured programming practices to ensure safety, scalability, and easy troubleshooting. 9. Future of PLCs. PLCs are evolving rapidly. Today's advanced models are part of the Industry 4.0 revolution, supporting IoT connectivity, cloud data integration, and predictive maintenance. In Western factories, PLCs now talk directly to smart sensors and cloud platforms, while in the Gulf, industries are upgrading legacy systems to digital PLC networks. The future PLC engineer needs not only logic programming skills but also knowledge of networking, cybersecurity, and data analytics. 10. Why you should learn PLC programming. If you are an instrumentation or automation technician, learning PLC programming opens global opportunities. Industries in Dubai, Saudi Arabia, Qatar, and across Europe and the USA are always looking for skilled PLC programmers who can maintain, troubleshoot, and optimize control systems. It's not just a technical skill, it's a career gateway. Whether you work in oil and gas, manufacturing, food processing, or water treatment, PLC knowledge makes you valuable and future-ready. Conclusion. PLC programming is the heart of industrial automation. It combines logic, control, and technology to make systems run efficiently, safely, and smartly. From Gulf refineries to Western factories, PLCs keep our world moving, silently and precisely. So if you want to start a strong career in automation, begin with PLC programming. Because understanding the brain of the industry means understanding its future.